Good evening. So today we discuss one more problem. This problem also has no correct options according to me. So this is a problem with which has op-amp and diodes. So I'm sure I have seen that there's a lot of discussion on the net, and there's a lot of confusion about which should be the right option, and also all the instructors they also have different opinions. So I'll just give my take on it and what I think of it. So according to me, none of the options are right here. So it says the IV characteristic of diode is this. So basically, it's asking you to use this formula for the diode instead of using infinite conduction for forward bias and zero conduction for reverse bias. This formula is what you need to use, and then that is connected to basically a op amp in this situation, and there's a voltage V in given here, and it's asking you to find out V out. And these are the options. So I think according to the NTA, this option 3 is the right one. And many people have challenged it. Many are claiming it's option 4, which is right. But according to me, actually, none of them are right. And I'll just show you my calculations. So, okay, so first of all, some concepts. When you are using this formula, I equal to is e to the power qv by kt minus 1. So first of all, what is V? So here you have a diode, you put VB voltage on the behind and VF on the forward. So what is V? Is it VB minus VF, or is it VF minus VB? Or does it depends on which is higher? If VB is higher, then you use some difference, and if VF is higher, then you use some other difference, or what? So which one is it? So first thing which should be clear to you is that V is always VB minus VF, the voltage behind the diode minus the voltage at the front. Okay, so this is always the case. It doesn't matter whether the diode is forward bias, reverse bias, whatever. So this is always that. Okay, and the second thing that you have to worry is the direction of the current. When you use this formula, does the positive value signifies current flowing this way or this way? So that's one. So the positive direction of current is always this. Okay. So you can see that when it's a forward bias, so this is higher and this is lower. So this will be greater than 1. So this will be a positive value, right? And when it's reverse bias, so this quantity will be negative. So this will go below 1. So overall this will be negative. So that means the current is going this way. So when you use your analysis, so you always consider that the current is flowing this way, and then you do your calculations, and if the current turns out to be negative, then you know that it's actually going backward. And if by any chance you want to use the current going this way and then do your analysis, then you have to put a minus sign, okay, and then do your analysis, and then it will be right. So then you will get a positive direction for current flowing this way and negative for the other way. Okay, so these are the concepts that should be clear to you, and with this let me just derive the solution for this op-amp. So first thing is that you put this to 0. So this terminal will always try to attain the value which is here. So the difference will, the op-amp will always try to minimize this difference. So for the first level calculations, so this you take it to be equal to this. So this is 0, and now there are two ways to calculate it. You can achieve the current going this way, then here, and then apply Kirchhoff's law. So this is the one right to left. This is the normal way of analyzing it. So what is current? So current is e to the power qv by kt minus 1. So here it's V out minus 0. So behind is V out and front is 0. So it's V behind minus V front. Okay, so this is the difference you have to use. And of course, when it's going this way, so the current here is what? It's 0 minus V in by R. Okay, so this is what you use. The current here equals current here, the Kirchhoff's law. If you want to use left to right, then of course the current going this way will be what? V in minus 0 by R. So this, and this is equal to the current going in this direction. So here you have to use it with a minus sign. So it's minus IS, and the voltage here is going to be the same as in this case. So it's always behind minus front. Okay, so use that, and so basically you see now that this and these are same. So if you bring minus sign to the side, it will just become equal to that. So when you use that, you get e to the power qv by kbt equal to 1. So 1 will go this side, so it's 1 minus v in by, and this is will go down, so 1 minus v in by isr. So and then you take a log, and the factor of kbt by q will come this side, and you have this factor here. So that is your answer, and it does not match with any of the options. So you can maybe I don't know, you cannot write to them again. It won't make a difference, but you can still try to mail them, and maybe the question is cancelled, or they will give a grace marks to all those who attempted it, whatever. But anyway, this has some issues which I will not discuss. I mean, first of all, what I'm interested in, what if Vn is very high, because this quantity cannot go negative, but this goes negative. So what happens then? So basically, this will change. The op-amp cannot maintain will not be able to maintain a zero voltage here, and that will change, and the analysis becomes complex. So I don't want to discuss that, but it's very interesting to look at it. However, now let me just look at something else, something which is so this does not match with any option, and of course this is just what I said. If V increases this quantity, then this will be negative, but of course this cannot go negative. So what will that mean? So that implies that the op-amp will not be able to maintain a zero voltage here. So voltage here will change, and then with the change voltage, the analysis becomes quite complicated and also interesting. So I mean, if you have time, you can have a look at it. So anyway, let me now get to something else that I want to tell you about. Something more related, more specific to this problem in the exam. So this was the voltage, was the circuit which was given. So if by any chance if you connect the diode in opposite direction, then you see what happens. So then again you do your usual analysis. So you can use the current going in, use a zero voltage, and then going this direction, and then you do a calculation here. So current is V in minus 0 by R, and that equals this Is times e to the power qv by kt minus 1. So here V is now different. V is behind is 0, forward is out, so it's 0 minus V out. Okay, or you can use the other way if you want. The same thing, just a minus sign here with the same expression, and that is equal to 0 minus. So if the current, if you think it's going this way, and then do your analysis, so you use the minus sign, and so that equals 0 minus V in by R. Okay, and then basically, so what you get, you can bring Is down, and then bring 1 to this side, and what you get is this. And then if you take a log, so this quantity will become that, and ultimately you end up with a minus sign here, and this is actually one of the options. Okay, so what I mean, according to me, what I think has happened is that whoever has said the question, probably he thought that Okay, so expression with this is this, and if you reverse the diode, it will just become plus. Maybe the question setter had this in mind, and that's why they have went with this option, because if the diode is in the opposite direction, then of course this is right. So maybe they have just assumed that without doing those final calculations, that if you connect the diode in a opposite way, then this should be the right one. Okay, so that, and then they simply, without checking, maybe you know, this year, of course, maybe they have made the question paper in a hurry or whatever. Uh, so they just went for this option. So I guess that's what has happened, but this is not correct. And in fact, none of the options are right here. Okay, and if many people write to them, probably they will take off this question. Maybe they will give some grace marks or whatever. But this was my take on this particular problem, and I think that some confusion has happened with it, with whoever the question setter is. They just assume that changing the diode will change the sign. This is not true. So this is what I had to say, and I also have a course for net. If you are interested, you can email me. Otherwise, thanks for watching, and I'll see you next time. Okay, bye.